This is Harikaran. I am going to discuss about mole concept in chemistry. I am chemistry faculty. Now we are going to discuss about mole concept. So this is the most of the physical chemistry depends upon the mole concept. Mole concept means it is a unit of number. It is a unit of number. Generally, suppose 1 kilogram. 1 kilogram is the unit of mass or maybe unit of quantity. So 1 kilogram explain the unit of quantity. Similarly, 1 dozen. 1 dozen means which indicates a number. The 12 is the number which indicates 1 dozen. Similarly, to know the units of or maybe elementary chemical units. Elementary chemical units. Elementary chemical units. Either may be like atoms or maybe molecules or maybe ions. Either may be atoms or maybe molecules or maybe ions. So in SA system, a unit was introduced that is called as a mole. So to explain the number of either maybe atoms or maybe molecules or maybe ions, a chemical elementary chemical units in SA system, the unit mole was introduced. So what is meant by mole and how can we define mole? Mole can be defined as, we are going to write about a definition as per the mole. Mole is nothing but 6.023 into 10 power 23 particles. Or mole is nothing but 1 gram atom. Or mole is nothing but gram atomic weight of an element. Or mole is nothing but gram molecular weight of the compound. Or mole is nothing but 22.4 liters of any gas at STP conditions, standard temperature pressure conditions. Mole is nothing but 1 gram formula weight of the ionic compound. Ionic compound. So mole is represented by small n. So how can we write? How can we explain the mole concept as per the concept-wise problematic variations? So mole is equal to, or number of moles equal to weight of an element divided by gram atomic weight, or number of moles equal to weight of substance divided by gram molecular weight of the substance. For example, calculate number of moles of glucose present in 540 grams. Calculate the number of moles of glucose, or calculate the number of moles of glucose present in 540 grams of glucose. So we are going to discuss about glucose. The formula of glucose is C6H12O6, whose molecular weight is 180. The molecular weight of glucose is 180. So number of moles of glucose equal to 540 divided by 180. And its value is 3. Means it contains 3 moles of glucose present in 544 grams. 540 grams of glucose. Similarly, number of moles equal to number of molecules given. Number of molecules of given substance divided by Avogadro number. 1 mole of any substance contains Avogadro number of particles. So number of moles equal to volume of the gas given in liter at STP conditions divided by 22.4 liters. So STP means standard temperature pressure conditions. Standard temperature conditions are 273 Kelvin temperature or 0 degrees Celsius temperature. Standard pressure is 1 atmosphere pressure, that equal to 76 centimeter of Hg, that equal to 760 millimeter of Hg. So how can we find out number of moles? If calculate the number of moles present in, calculate the number of moles present in 3.01 into 10 power 22 molecules. 10 power 22 molecules. The number of moles equal to, the formula is number of molecules of given substance divided by Avogadro number. Then 3.01 into 10 power 22 divided by 6.023 into 10 power 23. Its value is approximately 1 by 2. Then it becomes 1 by 2 into 10 power minus 1, or 0.5 into 10 power minus 1, or 5 into 10 power minus 2. That is the number of moles present in 3.01 into 10 power 22 molecules. So we are going to know the relation. What is the difference between a mole and or how can we calculate a simple example? 1 gram atom equal to 1 gram atom equal to Avogadro number of atoms. Avogadro number of atoms, that equal to gram atomic weight. That means 1 gram nitrogen atom is equal to 6.023 into 10 power 23 nitrogen atoms, that equal to 14 grams. That means 1 gram oxygen atom is equal to 1 gram molecule, or 1 mole is equal to Avogadro number of molecules, that equal to gram molecular weight. For example, 1 gram O2 molecule is equal to 1 mole oxygen, that equal to 6.023 into 10 power 23 molecules, that equal to 32 grams. This is the basic relation to explain the mole concept. So that means 1 mole of any substance contains Avogadro number of molecules. That means the mass of 1 mole of substance is equal to gram molecular weight. Similarly, 1 mole of 1 gram atom contains Avogadro number of atoms. That means the mass of Avogadro number of atoms equal to gram atomic weight. So based on that, 1 mole of any substance, 1 mole of any substance, that means 1 mole of any gas, 1 mole of any gas at STP occupies 22.4 liters volume, or 22,400 milliliter, that is called as gram molar volume. So 1 mole O2 occupies 22.4 liters at STP, that equal to 44 grams. That means the mass of a gas occupied at STP conditions is equal to gram molecular weight. So 44 grams of O2, 44 grams of carbon dioxide, 1 mole of oxygen equal to 20.4 liters at STP, that equal to 32 grams. So 44 grams of CO2 occupies 22.4 liters at STP. Similarly, 32 grams of O2 at STP conditions occupies 22.4 liters at STP. So how can we calculate number of molecules or maybe number of atoms based on the mole concept? So number of atoms in an element is equal to number of moles into Avogadro number. Here Avogadro number is nothing but 6.023 into 10 power 23 is called as Avogadro number. Number of moles is not given. How can we calculate number of atoms? Then weight by gram atomic weight into Avogadro number. Similarly, number of atoms in a compound equal to number of moles into Avogadro number into atomicity. Atomicity. What is meant by atomicity? Atomicity is nothing but total number of atoms. Total number of atoms in a molecule. Total number of atoms in a molecule is called as atomicity. For example, oxygen has 2 atoms, hence it is called as diatomic. Its atomicity equal to 2. Carbon dioxide has 1 carbon atom and 2 oxygen atoms. Its atomicity is equal to 3. Sulfuric acid has 2 hydrogen atoms, 1 sulfur and 4 oxygen atoms. Then atomicity equal to 7. So, number of atoms in a compound equal to number of moles into Avogadro number into atomicity. Number of atoms in element equal to number of moles into Avogadro number. What is the difference between these two formulas? For example, calculate number of atoms in 2.3 grams of sodium. Sodium is a metal. Sodium is an element. So number of atoms is equal to weight is given 2.3 divided by 23 into 6.023 into 10 power 23. This is 1 by 10 and its value is 6.023 into 10 power 22. So 6.023 into 10 power 22 atoms present in 2.3 grams of sodium. Similarly, how can we calculate number of atoms if compound is given? Calculate number of atoms in 4 grams of sodium hydroxide. 4 grams of sodium hydroxide. Here sodium is taken. That means it is an element. Sodium hydroxide means this is a compound. So we are going to find out number of atoms but not number of molecules. So number of atoms in 4 grams of sodium hydroxide is equal to 4 divided by weight by gram molecular weight into Avogadro number into atomicity. Avogadro number into atomicity. So 4 divided by 40 into 6.023 into 10 power 23 into atomicity of NaOH is 3. 1 sodium, 1 oxygen and 1 hydrogen whose atomicity equal to 3. 4 1 ja, 4 10 ja. So 6.023 into 10 power 21. 3 into 6.023 into 10 power 22 atoms are present in 4 grams of NaOH. The same problem will be asked in a different way. That is, calculate number of oxygen atoms present in 4 grams of NaOH. This is the different way. Here question number whatever asked is calculate number of atoms in 4 grams of NaOH. So we are find out total atomicity of NaOH. But we are going to discuss about calculate number of oxygen atoms in 4 grams of NaOH. Oxygen means we have to find out only oxygen. Then number of atoms is equal to number of oxygen atoms equal to 4 divided by 40 into 6.023 into 10 power 23 into it has only 1 oxygen atom. Hence atomicity equal to 1. Then 4 1 ja, 4 10 ja, its value is 6.023 into 10 power 22 oxygen atoms. This is a calculation of number of atoms. So number of atoms in a compound equal to number of moles into Avogadro number into atomicity. Similarly, calculate the number of atoms in element equal to number of moles into Avogadro number. So next one, calculate number of molecules, or how can we calculate number of molecules? Number of molecules equal to number of moles into Avogadro number, or weight by gram molecular weight into Avogadro number. So calculate number of molecules present in 9.8 grams of sulfuric acid. So number of moles equal to 9.8 by 98 into 6.023 into 10 power 23. The formula is number of molecules equal to weight by gram molecular weight into Avogadro number. This is 10 times and its value is 6.023 into 10 power 22. So simply we are going to discuss about one relation, that is one NH3 molecule is equal to 17 grams. This is the gram molecular weight. It contains Avogadro number of molecules, 10 power 23 molecules. 1 mole ammonia equal to 1 mole ammonia is equal to 1 mole ammonia equal to 17 grams, that is equal to gram molecular weight. 1 mole ammonia equal to Avogadro number. 1 mole ammonia equal to 4 into N0 atoms. This is molecules. 1 mole ammonia equal to 17 grams. This is gram molecular weight. 1 mole ammonia equal to Avogadro number of molecules. 1 mole ammonia equal to 4 into Avogadro number of atoms. 1 mole ammonia equal to 1 into 1 or N0 nitrogen atoms or Avogadro number of nitrogen atoms. 1 mole ammonia equal to 3 into Avogadro number of hydrogen atoms. 1 mole ammonia equal to 10 into N0 electrons. 1 mole ammonia equal to 10 into N0 protons. 10 into N0 protons. So 1 mole ammonia equal to 17 grams, that is equal to gram molecular weight. 1 mole ammonia is nothing but Avogadro number of molecules. 1 mole ammonia equal to 4 into 4 means the atomicity. We have 3 hydrogens and 1 nitrogen atom. So 4 into Avogadro number of atoms, and it has only 1 nitrogen atom and it is N0 nitrogen atoms. It has 3 hydrogen atoms, 3 into N0 hydrogen atoms. The total number of electrons present in ammonia means the atomic number of nitrogen is 7. It has 7 electrons, and hydrogen is 1. It has 1 electron, but we have 3 hydrogen atoms and total number of electrons belongs to 3. The total number of electrons in ammonia molecule to 10, hence it is 1 mole ammonia contains 10 into Avogadro number of electrons or 10 into Avogadro number of protons. Then we can also calculate number of neutrons. The mass of nitrogen is 14, it has 7 neutrons, and each hydrogen has, there is no, generally protium has 0 neutron, so it has 7 neutrons. Similarly, 1 mole Na2CO3 is equal to 1 mole sodium carbonate equal to 106 grams, that equal to gram molecular weight. 1 mole Na2CO3 equal to 6.023 into 10 power 23 molecules. Na2CO3 decomposes to form 2Na plus CO3 minus 2. So 1 mole Na2CO3 contains 2 into N0 Na plus ions. 1 mole ammonia equal to 1 into N0 CO3 minus 2 ions. N0 is nothing but Avogadro number. N0 is nothing but here Avogadro number. N0 equal to 6.023 into 10 power 23. Then 1 mole Na2CO3 equal to 3 into 6.023 into 10 power 23 ions. Here 3 is, we have 2 Na plus and 1 CO3 minus. The total number of particles are 3. So 1 mole Na2CO3 equal to 106 grams, that is called as gram molecular weight. 1 mole sodium carbonate contains Avogadro number of molecules. 1 mole Na2CO3 contains, we have only 2 sodium atoms. So 2 into Avogadro number of Na plus ions, and 1 mole we have only 1 carbonate ion. It has 1 into N0 into CO3 minus 2. That is 1 N0 or Avogadro number of carbonate ions. The total number of particles are 3. Hence 1 mole Na2CO3 contains 3 into Avogadro number of ions. So this is a simple concept of mole, and based on that, suppose calculate calculate the mass of Na2CO3 present in sodium carbonate present in 0.1 mole. So calculate the mass of Na2CO3 present in 0.1 mole. So number of moles equal to weight by gram molecular weight. Number of moles equal to weight by gram molecular weight. Then weight of substance equal to cross multiplication number of moles into gram molecular weight. Then weight is equal to number of moles is 0.1. 0.1 may be written as 1 by 10 into 106, that equal to 10.6 grams. Or it can also be 1 mole of any substance is equal to gram molecular weight. So 1 mole Na2CO3 has 106 grams. 106 grams. Then 0.1 mole Na2CO3 contains 10.6 grams. 10.6 grams. So this is the calculation of mass of the substance based on the number of moles is given.